All right, so let's talk about what radians are. So when you have a circle and a central angle here, these two pieces would each be the radius. If the arc length is equal to the radius, then the central angle will equal 1 radian. So if the arc length is equal to the radius, that means this angle right here, the central angle, measures 1 radian. Okay, that helps us come up with the formula. We have the formula S equals R theta. That is the symbol for theta, where S means arc length, and R is, of course, the radius, and theta is the radian measure of the central angle. Okay, so let's look at what that looks like. Okay, so if we have a problem like this, at a central angle here, let's say that we know that this one is 5 centimeters. We don't know theta, and we know that this is worth 20 centimeters. Well, then we would know that the arc length S, we replace it with 20, equals the radius 5 multiplied here by theta. So to get theta alone, we're going to divide through by the 5, and 4 would equal theta. So the radian measure there would be 4, if that was true. Okay, so how do radians compare with degrees? So when we think about our circle, we know that our circle has 360 degrees in it. But our formula that we were just working on is that S equals R theta. And S stands for the arc length. Well, if 360 degrees is the whole circle in degrees, what is the whole circle in terms of arc length? So if we're going around this outside all the way around, then the full arc length has to be the circumference, which we can write as 2 pi r. So that equals r times theta. And now we notice we have the r, or radius, on both sides. So if we divide through by the r, that will simplify to 2 pi equals theta. So that means that if the entire circle is 360 degrees, the entire circle is 2 pi radians. So the full circle is 360 in degrees, and it is 2 pi in radians. So if we want to take out that theta, we now know that 2 pi represents the same amount of space, or the same central angle, the full central angle, as 360 degrees. So if we know that 2 pi equals 360, we can of course simplify that and divide through by 2. So now we also know that pi is 180 degrees. So if we were looking at our circle, if that was truly a half circle, this part of the circle here would be worth 180 degrees, or we could say it's also worth pi radians. Those have equivalent measures there. All right, so what happens if we want to convert in between the two? So we know now, if we do it in simplified form, that 180 degrees has the same value in the circle as pi radians. And then we'll just substitute in with whatever given part. If we know a number in degrees, it will go up top. If we're given something in radians, it will go there on the bottom. So I gave you something along the lines, let's say I said 30 degrees, and I want to know how many radians is 30 degrees. Well, I know that 180 degrees is worth pi radians. Now I have 30 degrees, and that's going to be worth x radians. So I can multiply through 180x equals 30 pi. 30 pi. I want to get the x by itself, so I'm going to divide through by that 180. And then I need to simplify. So if I divided through. So as I was dividing through, I would have the 1/6 pi. Now you do not put in 3.14, 3.14159, or pi button for pi. We are going to leave it in terms of pi because we want to be as most precise as we possibly can. So hopefully that's enough to get you started, get you going on today's worksheet. Give it your best shot. We'll go over it tomorrow, and we have another worksheet tomorrow.